Good afternoon, dear colleagues and guests. I apologize for this delay due to technical issues. Johnny is now open of the special 01047 Condensed physics on the theme Studies of Magnetic Properties of Gallium Arsenium Manganese, Lanthan Strontium Manganese O3 and E3 Iron Garnet open. According to the order of St. Petersburg University dated the 4th of October 2019, number 916/1, myself, Physics of St. Petersburg University, was appointed of this dissertation council. Let me also introduce my fellow counsel, Vlasenko Leonid Sergeyevich, Doctor of Mathematical Sciences, Senior at Russian Academy of Sciences. Kuchma Anatoly, Doctor of Physical and Medical Sciences, Professor of the Department of Statistical Physics of St. University. Pavlov Viktor Vladimirovich, Doctor of Physical and Mathematical Sciences, Principal Researcher, Head of Laboratory of at Yofer Institute of Russian Academy of Sciences. In the remote mode, we have Professor Arjani. Good afternoon, Professor Arjani. Materials workshop at the National Research Council, Italy. We also have here academic advisor of the applicant, Chinsky Vladimir Ilyich. First, let me especially emphasize that according to the federal law of the 23rd of August 1996, number 127, on science and the state's scientific and technical policies, St. Petersburg University has the right to award academic degrees independently. A corresponding order on the procedure for awarding academic degrees at St. Petersburg University, on the basis of which we are holding this session, was issued on the 1st of September 2016, number 6821/1, hereinafter referred to as the order. In accordance with this order, a session of the Dissertation Council is duly constituted if at least 2/3 of the approved members of the Council are present, but not less than 4 persons. Our Dissertation Council consists of 5 members. All the members are present, including 1 member of the Council in a remote interactive mode. The audio-visual contact to him has been established. Thus, there is a quorum. Let me set forth the procedure of today's Chairman summary report on the main content of the documents submitted by the candidate and their compliance with the applicable regulations. Answers to possible questions, 5 minutes. A brief presentation by the applicant outlining the key points of her study. In 15 and 20 discussion of the applicant third time because of different opinions thesis. The members still one by one with their reviews, no more than 10 minutes for each speaker, and answers to council members. Additional discussion members of the Dissertation Council, and no more than 20 minutes. Open discussion, speeches of the attendees with summaries of their positions and specific questions and suggestions to candidates strictly on the topic of the study, not more than 5 minutes per person. At this point, for this, we have a registration sheet. Whoever wants to speak or ask a question, please put your name on this registration. Thank you. Final answers of the applicant to questions asked, not more than 5 minutes. Speech of the academic supervisor, Professor Kuczynski. A discussion before the open voting on awarding or not awarding the academic degree to the candidate. For the time of this discussion of the council broadcasting shall be suspended. This is important for our technical staff. The open individual voting and counting the votes. The results will be recorded in the minutes of the meeting. A decision on awarding or not awarding the St. Petersburg University academic degree to the applicant and closing remarks of the applicant. No more than 2 minutes. Dear members of the council, do you have any objections to the procedure? No one has any objections. It's very good. Before we proceed, let me remind you to switch off your mobile phones. Thank you for your understanding. And let me also switch off my phone. Let me also inform you that the meeting shall be recorded and broadcast online at St. Petersburg University website. The speeches are being simultaneously translated from Russian into English, or from English. So let's start with our first item, the chairman's summary report. A thesis by Burobina Veronika, degree of candidate of physical and mathematical sciences, specialty 010407, condensed matter physics, on studies of magnetic properties in gallium, lanthan, strontium, manganate, O3, and iron garnet, was accepted for defense by the order of the Academic Secretary of St. Petersburg University on the 4th of October 2019, 9820/1. The Dissertation Council was appointed by the order of the Academic Secretary of St. Petersburg University on the 4th of October 2019, number 9820/1, and I have already introduced its members to you, dear colleagues and guests. The applicant submitted the following documents to the Academic Secretary of St. Petersburg University: an application to the Rector of St. Petersburg University, Professor Kropotchev, to accept the thesis for consideration and defense submitted on the 17th of April 2019. A review by the academic advisor, Kuczynski Vladimir Ilyich, Doctor of Physical and Mathematical Sciences, Professor of St. Petersburg State Electrotechnical University, named after Vladimir Ulyanov. A list of 7 publications which summarize the main scientific results of the thesis, including 3 publications in journals indexed in scientometric databases Web of Science and Scopus. A certificate of candidate's examination issued on the 23rd of December 2018, issued at Yotver Institute of the Russian Academy of Sciences, that Burobina Veronika has passed the candidate's examination in specialty 010407, condensed matter physics, with the following results. Condensed matter physics, excellent. Foreign language, English, good. Certificate of candidate's examination, the 8th of May 2019, 0105, issued St. Petersburg State Electrotechnical University, named after Vladimir Ulyanov, that stating that Burobina Veronika passed the candidate's exams in history and philosophy of science, physical and mathematics with an excellent mark. A postgraduate diploma, master's diploma BMA number 0022994, issued on the 30th of June 2007 at St. Petersburg State Electrotechnical University, named after Vladimir Ulyanov Lenin, certifying that Burobina Veronika was awarded the master's degree in electronics and microelectronics by the decision of the State Attestation Commission on the 19th of June 2007. The thesis in English, on paper, on the rights of the manuscript, and in the electronic form. The thesis has been formatted in accordance with the requirements of the state standards. Should be noted that all documents listed above comply with Clause 12, Section 3, Thesis Presentation Defense of the procedure for awarding the academic degrees at Petersburg University, Annex 1 to the order. Now let's proceed to the brief presentation of the applicant. That should take between 15 and 20 minutes. Dear Veronika Gennadievna, in which language, Russian or English, will you? My presentation will be in English. Добрый день. Большое спасибо за то, что вы присутствуете на моей защите. Работа отражает мнение, которую я выполнила в институте ЙОФа в Санкт-Петербурге. Can you hear Dr. Johnny?
Yes, now I'm hearing you. Yes, now I'm hearing you.
Да, теперь слышу. Вы молчите, правильно? You have 2 more minutes for your presentation because of the break we've just had. So the summary of my second chapter, резюме моей второй главы и основное утверждение, и основное положение, вносимое на защиту, также представлено на этом слайде. Затем я расскажу о своих исследованиях, связанных с соединением пленки железной итрия. Эти пленки могут быть выращены с использованием нескольких методов осаждения, таких как универсальные методы соединения ленты включения, метода лазерного осаждения. В своей работе пленка была выращена. Мы используем следующий метод для гранатогаллиевого галлия. Оказалось наиболее оптимальной для выращивания пленки. Морфологические характеристики пленки представлены на следующем слайде. Я демонстрирую несколько этапов выращивания пленки, морфологические характеристики. Я в своей работе ориентировалась на магнитные свойства, исследование магнитных свойств. Как показано, толщина пленки увеличивается при толщине пленки 6-7 нанометров. Таким образом, с точки статистической магнитометрии на границе с пленки с подложкой присутствует магнитный слой. Моя работа посвящена изучению динамических магнитных свойств пленки, в частности, зависит от резонансного сигнала. Изменение также становится, интенсивность сигнала зависит от толщины пленки. Волна затухает по мере уменьшения толщины пленки с 25 до 6 нанометров, что указывает на наличие переходного слоя между подложкой и самой пленкой. Таким образом, чтобы определить природу, изучала как работает на поверхности с нескольких вольт. На этом слайде показаны структуры магнитной профили, плотности, рассеивания, полученные из рефлектрометрии поляризованных нейтронов при различных температурах, приложенном магнитном примерно 700 нанометров пленка на подложке. В исследованных образцах галлий представлен пленкой толщиной 5-7 нанометров. Концентрация гадолиния увеличивается, и можно таким образом предположить, что пленка присутствует верхний слой с низкой плотностью. пленки вылощенной соотношение иона в итре уменьшается. Пленка, полученная при температуре 700 градусов Цельсия, практически не меняется. И атомы иона частично замещаются атомы галлия. И 70 нанометров. Структура магнитного профиля позволяет предположить, что более низкая плотность и была представлена на этом слайде. Как видите, воображаемая часть здесь пропорциональной концентрации, и воображаемая часть здесь резко сокращается, и диффузия атомов в гадолине также отмечается. Рентгеноскопия демонстрирует резкое падение при z равно нулю, после чего плотность продолжает медленно уменьшаться. При z равно 70 Армстронгам плотность пленки становится равной плотности материала. Значение SLD немного выше, обозначено красной линией на рисунке, согласуется с плотностью электронов в красным цветом. Полученный SLD профиль позволяет предположить, что на поверхности пленки присутствует верхний слой. В противном случае без этого слоя невозможно было бы смоделировать низкочастотные колебания на кривой без этого слоя. Слой на поверхности пленки не является итриевым, 203. Значение SLD для итрия 203 составляет 3,75, что в 10 минус 5 армстронгов, что значительно больше значения плотности для поверхности пленки, показанного на рисунке. Слой с пониженной плотностью связан со ступенчатой структурой поверхности роста пленки. В качестве резюме присутствие магнитного слоя в пленке было доказано. Диффузия галлия в пленке была доказана, и слой с более низкой плотностью на поверхности пленки основное положение 3 главы можете прочитать здесь. Большое спасибо за внимание. Также я хотела бы выразить благодарность профессорам Зигри и профессору Кучинскому. Спасибо. Thank you. Now time has come for our discussion. Time for members of the Education Council to ask questions. Veronika Gennadievna, I kindly ask you, if the question is asked in Russian, could you please answer questions in Russian? Who of the council members wants to ask questions on Veronika Gennadievna's presentation? Sergey Vlasenko. Is the last graphs that you showed on distribution of impurities. What does minus mean? So 0, that's surface. Да, абсолютно. Это My request was that you answer questions in Russian. Switching channels from Russian into English is not easy. So this base layer, transition layer, and on the film there is another film which at the moment cannot be identified. And just another clarification, this layer, and then which has a negative value, is -50. Is this the border of the layer, or it goes still deeper in this graph? Yes, it goes still deeper. Thank you. Could you kindly go back to the slide with the balance equation, what you call the main result of adjusting to experimental data to spin relaxation times? Preceding, yes, is this slide. Could you please tell us, because there's no formula, you presented no formulas, the overall impression is that this presentation was aimed at high school students without any details. So this is not a question but a comment. So for me, I find this very strange. And so these questions, you later explore those equations with photo treatment. Some holes settle on manganese level. Something happens on this level. Is that right? Is that your idea? But if we look, I don't know if maybe from the maybe we can see a page of your thesis, page 25 and next years, but the next slide in your formula fit all. Have you checked this formula? Yes, of course I did. Not the formula itself. Yes, this is the page of your thesis. Go back to the formulas in your thesis. Can we enlarge? We so if you look at the final part of the page, it says that originally the value delta is the number of ions, of manganese ions, which come from where? The donor's electrons released to shell acceptors, and so this is residing amount on acceptor. So delta is what found on manganese before optical treatment. Is that correct? So what happens next? Next, you should have said, here we've got the equation. Some metals minus them to the elevators, so they return to the same state before photo. Do you understand? Yes. So what happens? The equation n minus delta plus q. So which process they describe? You had a manganese ion which received an electron from the donor. Then it passes transfers the electron to the hole after photo treatment. So where's the ion with the hole? What happens? after filling acceptor and simultaneously the photoexcited holes are filled and within the valence band. So you believe the holes in the valence band, they go up. The electron moves to the valence band and the holes are closed. That's what your equations mean. Look at your equations. The top one says this is the balance of holes in the valence band. How can they, with what can they recombine? With ions. So the electrons have to come from somewhere. And the low equation is n minus delta plus q. These are the same centers you had before photo treatment. Iron with a hole becomes equivalent to a manganese atom. So equations describe a simple situation. So electrons move upward and go through the donor level. So then they reach manganese level, and from there they go back. They draw the valence band. So this is not for discussion. Let's ask questions, but I could not get this adjusting. Have you checked the so we can discuss that later. First of all, I don't understand such a lengthy discussion. In the electron functions, the chairman said, okay, let's drop this for the time being, and so this well describes my experiments. Here my question, is there an agreement? Does it agree with itself? Can we add the formula? Yes, the formula is here on the screen. Look at the formula. What does it, this G, make, so what happens? Let me show you the slide. Here's your formula in the slides. Because this, let me show you, let me give you the answer to your question. Because you claim, for example, just a moment. So why did you take the formula away? I want to demonstrate how I came to the conclusion. So I'm interested in the accuracy of the formula. So I'm asking about the maybe I can write. This statement is that the formula is incorrect. So I would like, so you believe that with optical treatment, so is this, so this is your statement. Concentration of excited ions is, so this is your statement. So well, if we look at my calculations, the formula will look as follows. If photo treatment starts to eternity, we receive the following result: delta divided by 2. Please take a good look how I obtained this result. Okay, so you claim that your formula is correct. Okay, let's postpone till until the next discussion. Veronika Gennadiyevna, let's move on. So does anyone have more questions? Viktor Vladimirovich, in the first part of your presentation, which mechanism of spination you describe? Which mechanism of spin relaxation? Only the mechanism described by Astakov, or did you look at other mechanisms? Yes, I use of Pirelli by using equations. Spin relaxation time, and we obtained the final equation, fitting function, which described experimental data obtained in our experiments by applying a magnetic field. So that was not my first attempt to obtain a formula. So I came to this conclusion. This is my latest calculation. Do we have more questions? Yes. In the second chapter, you describe a multi-layer structure. How important or non-important is the domain state real? The task which I set to myself, that was not important for that task. So maybe that depends more on how you want to use the material. In our material or our calculation, the shift of Curie temperature and isothermal. Thank you. And may I ask a question about chapter 3? So you look at growth of films of iron garnet. So did you try to grow materials with zero non-magnetic layer of quality? So you had quality interface between film and base. I'm sure in our laboratory somebody looked at these issues. Personally have not dealt with that. And at the moment I am only presenting results obtained by me. Thank you. Professor Ajani, do you have any questions at this point?
Yes, actually, two questions. First one is related more to the last comment about the colleague. In the sense that
у меня вопрос, очень связан с вопросом, заданным моим коллегой. Очень тонко. Считаете ли вы, что есть стратегия, которая повысить качество? Это было бы очень важно. Иначе это результаты эту пленку нельзя использовать в микроэлектронике. К сожалению, я плохо расслышала ваш вопрос. Ваш вопрос касается качества пленки. Правильно ли я поняла? Конечно, нам нужно минимизировать магнитный мертвый слой для потенциального будущего использования этих пленок в новых устройствах или в тех устройствах, которые мы хотим создать. Или, может быть,
плохо расслышала. Что именно вы меня спросили?
Okay, I was just the second question was about
Второй вопрос.
About this properties
Касается
the use of refrigerator. The use you have studied just I would call a very regular manganese like LaSrMnO with a Curie temperature close to 300 Kelvin. But
касается свойств материалов, которые вы изучали.
Of improving the performance by changing Curie temperature or by changing granularity.
Удалось ли вам добиться изменить свойства при помощи изменения температуры Кюри?
About this properties useful for refrigerators.
Можно ли изменить свойства? Да, я хотела бы работать над этими проблемами в будущем, но в настоящее время у меня была возможность только вырастить пленку LaSrMnO PMN5 и использовать ее магнитные свойства. И, конечно, я хотела бы разрабатывать эту технологию в будущем. И чтобы искать новые материалы в сравнении с результатами, которые я получила.
Okay.
Do we have more? Does anyone else want to speak or ask questions? Okay, I will let me some questions and make a small comment. Veronika Gennadievna, usually slides are numbered and then it's very much easier to access slides. You need slides for chapter 1 of your thesis. In your thesis, you call them conclusions. In this slide, it's very short. I will allow myself to read one sentence from your thesis. A typically long time of relaxation time of P-type arsenide. I'm making it shorter with a condition that on that concentration of donors is higher than that of acceptors, which is necessary to ionized and negatively charged manganese impurities. Why do we need negatively charged manganese states to obtain a typically long relaxation time? Because efficient magnetic field generated by manganese ions affects relaxation time, but in your thesis and in Astachov's paper, you both say that when manganese is negatively charged, the exchange is not compensated and electrons relax very quickly. So here and at the same time, holes from the valence zone are filled, so which compensates and the field becomes compensated, which results in makes the relaxation time longer. So this happens when negatively charged ions are compensated. So first we need to grow the right structure, because I think since the beginning So this is a challenging task to obtain unusually long spin relaxation times of highly acidoid is necessary to conduct experiments in the correct way. My question is different. Why do you need negative manganese in this case, in our case, which we are discussing? The result in creation of effective magnetic field which affects spin of higher electrons of upper levels, so they generate effective magnetic field for electrons, and relaxation time increases, becomes short. But in our case, we also have manganese ions which enable holes from the valence band, create anti-ferromagnetic states which result in prolonged relaxation time, which we observed in our samples. We studied these samples ourselves. Okay. Still, so what's the physical mechanism of extending the relaxation time? From your answer, I could not understand manganese from the holes from the valence zone. So you don't need the ions. You need the ions. No, you need the ions to generate the effective field that will be suppressed as a result. So it's not clear why do you have to create a field and suppress it later. Okay. You created a system of balance equations, and unfortunately I could not see the relation between the relaxation speed of photo-generating electrons and electron recombination and holes. So what is this? What's the relation of these speeds? I think this issue is described in detail in my thesis. That's why I ask this question. I have given a coefficient. I've given the coefficient. So maybe it doesn't have numerical representation. But so what about qualitative? So we need concentration of donors to be higher than concentration of acceptors to exceed. I'm not about concentration, but I'm asking about speed. So to talk about extended relaxation speed, which was the subject theme of our thesis, to meet this condition, let me say again, the concentration of donors should be higher than the concentration of acceptors. That you didn't hear my question. I'm not asking about concentration. I'm asking about relaxation speed. To suppress the relaxation speed. Okay, I see. Let us in your thesis, you have a large chart. So why did you give the table if you don't want to discuss it? This shows how we obtained the material studied in my thesis. It talks about semiconductor arsenide, arsenide. This is 1017. So this I obtained from my calculations, and this this is the sample to which I refer, which is a necessary condition. The concentration of donors should be higher than concentration of whole acceptors. You don't have that in your thesis. No, I discussed this in my thesis, for example. The main point is I obtained a series of samples, and I have the idea that suppression field can be suppressed. So you produced these samples? No, I did not. I processed the results of these, processed these samples. Doesn't say, your thesis doesn't say where the measurement results were. At that time, busy with theoretical work, and I didn't take part in the exams, so I received and I processed the results. But you know the rules. When you obtain results from somebody, if so, you should mention the person. At that time, I did not know the person who grew these samples. So the sample that you have selected, the manganese concentration is 50 times higher than excessive concentration of domus. 50 centers already contain holes, and the effective magnetic field has already been compensated, and only 2% are negatively charged. Maybe then it's not important. So why is it? So what's the physical reason that 2% of manganese negatively affect? Is a main impurity. Magnetic manganism is a deep impurity. So which coefficient enables this 2% of effective field of that small amount of manganese produce such a strong effect? Unfortunately, I did not consider this study this in my thesis, and to answer this, I need some time to think it over. But that does not contradict my main formula. Describes my experiment and the time of spin relaxation to the power of treatment. So do you have the B efficient in your? Do you have a slide for that? I don't have the formula for that. So you say in your thesis that we made a supposition and it was a success, because our theoretical curve ideally describes our experiment. So we believe the formula is good and the result was correct. I see, but the formula is not clear, because let me finish my question, please. So the formula is not clear because it has 1 plus some parameter multiplied by treatment power, and this extra component is much smaller than 1, and then you use this formula for a wide range of powers. Our supposition proved to be correct because if there were physical, we wouldn't be able to achieve the function that I have just shown to you. And I would like to say you can speculate a lot on this formula, you made a suggestion. We made a suggestion, a hypothesis, our idea. In our case, it described our experiment very well. So here I will quote that your final formula is incorrect. I have discussed this, what he said. The concentration of will be somewhat different. I have already shown how we obtain the equation shown as the final formula of my work. Let me interrupt. So maybe so we can prove this formula, or we prove that the formula is incorrect. So we'll postpone this discussion. You haven't answered my question. You said that. So I still I can prove in 5 seconds are wrong. The formula is wrong. Okay, let's try and ask at least some questions. So of course we've got many questions. Let me ask you a simple question. There's a very good review by Nikita Overkiev and Budkin, acceptor centers of manganese, to which you this review was published in 2018. Most of the questions I have asked are, unfortunately, I'm not familiar with the English version, so maybe if I ran into this review, I would have included in my work. It has also been published in English, and comments. So be efficient can easily arrived from Astahov's work, to which you refer, and the balance equations which you show. So I'm sure why you made this. I did not aware of this question. Well, colleagues, do we have more questions? So our time is up. We used all the time for questions, for discussion. So if colleagues believe it's time to finish the discussion, and we can continue with this discussion after opponents present their reviews. Okay? So about the following hour. Let's follow the procedure. Members of the council will present their reviews. We shall do it alphabetically to make it more democratic. So first we're going to give the floor to Leonid Sergeyevich. Shall I read my, or shall I also give comments? Well, this is by Veronika Burobina, is devoted to the study of physical properties related to of materials, such as see in the title, semiconductor and lanthanum, strontium, and iron garnet. All these materials are widely used in various fields of technology, such as spintronics and microwave technology. I believe that the relevance of the topic is obvious, and so since these materials are quite important in electronics, I think the relevance of the thesis is obvious. I have to touch upon the content from the presentation. The thesis consists of three chapters. Magnetic properties of different materials. The first chapter is properties of spin relaxation in gallium arsenide, and so this caused many questions, which evoked many questions. I think the fact what the candidate has shown in her thesis, so these equations, manganese is a magnetic impurity in any state, has 5 electrons, and by changing the number of electrons it still stays magnetic. But the matter is that with photo treatment, concentration of manganese ions in different states changes, and the kinetic equations, they show that with photo treatment manganese can change its charge, its state, not 100% but some proportion, some part of it. And the main idea of this thesis, of this chapter, is that the author suggested it captures holes and it transfers to anti-ferromagnetic state, reduces the field, and the spin relaxation time increases. A second chapter, and in my opinion, experiment conducted with changing is quite well. The experiment is quite well described by the kinetic equations, and the experiment was described quite well. So this is the experiment was quite interesting, because changing the efficiency, time of spin relaxation grows. So for many years, the release effect was unknown in because in other semiconductors, when increase treatment intensity, and so this was a mystery, as a mysterious result, which deserves attention, and so maybe calls for additional discussion. So that in the second chapter the author studies magnetocaloric effect. The magnetocaloric effect was studied before, and the author novelty of this study, of the thesis, is in the suggestion to use electric fields to change the magnetic state of material, and these results so far I don't think they are being used, but maybe in the results will be interesting in the future to produce a micro refrigerator with these materials. Chapter 3, iron yttrium garnet on substrates. The main attention here is paid to the study of distribution of atoms in such structures, and here I think I would also mention some new results in fusions, such as the study of magnetic dead layer, and the conclusion on atom diffusion, iron, so these So in this chapter, I think the author, this chapter also contains some interesting new results. And in conclusion, the conclusion presents the main results. The results have some practical value, so I will not repeat what. So I will now focus on some critical comments. My comments are as follows. In the first chapter, describe the technique of measuring the spin relaxation photo-excited in its sample studied helium arsenide, manganese. In your presentation, Gennadievna did mention the Hall effect and how from Lorentz curve with decrease of polarization you can measure the spin relaxation. So my question is, the first chapter should describe the technique of measuring the spin relaxation speed of photo-excited electrons in helium arsenide with manganese. My second question is not but the study of magnetocaloric effect to some in order to observe this effect under with the change of magnetic field. And usually it's necessary for the behavior to be reversible when you applied, switched on and off, and then this such as heat emission can be calculated. From the text of the thesis, I could not understand, could not figure out the controlling the electric field. Is it reversible or not? Yes, it is. So you showed us some pictures in your presentation of the magnetism changes when a voltage is applied. So will it is the effect reversible or not? As this magneticals, so will they be repeated? And also in the same chapter, I have another question. So what's the cause in the change of magnetization of the film? Is grown on is it electric voltage to the whole structure of 7 kilovolt or ferromagnetic, or is it mechanical voltage generated by which affects deformation of the magnetic element? So my question is, so what causes the change of magnetization, electric voltage or mechanical deformation? And my question to chapter 3 in figure 9 shows the distribution of iron atoms, yttrium, gallium, gadolinium throughout the structure of the garnet, and it shows it says depth, but on the x-axis it says width. So I'm not sure which width do you mean. So these remarks do not affect the general conclusions and do not reduce my overall high opinion of the results and of the work. And in conclusion, I would like to say that the applicant, the thesis by Veronika Burobina on research of magnetic properties of helium arsenide, also manganese 3, and
in yttrium garnet meets the basic requirements established by the order of the 1st of September 2016 on the order of awarding academic degree at St. Petersburg University. And the applicant, Veronika Burobina, deserves to be awarded a degree of candidate of physics and mathematics, specialty 010407, condensed state physics. And so I also have to say that clause 11 of the order has not been violated by the applicant. Thank you. Veronika Gennadievna, will you please answer the questions now? Yes. Of course, should say depth. As for your second question, you can see it in the slide. I apply electrical field so maybe you can answer the question in Russian. So let me ask you again to answer, apply the field, and when the electric field is applied, affects magnetization of the film. So your answer is that's a mechanical stress results from on magnetic affects the magnetic material. So the first question, I think you answered it in your presentation. That was not mentioned in your thesis, but you said that in your presentation. So I'm satisfied with your answer. So next review is by Anatoly Evdokimovich Kuchma. I will briefly read the theme of the thesis as the property of thin films of magnetic materials. Our work discusses the speed of spin relaxation of currency carriers in related magnetic impurities, semiconductors, optical treatment, regulated change of magnetism of thin film on piezoelectric base layer. Also discusses magnetism profile, existence and nature of magnetic dead layer on the thin layer of YIG. If we forget strange statements such as the into magnetic atoms become so small that direction of their moments are do not depend on each other, page 12, and many other questionable statements in the text of the first chapter, let's look at the main section of this chapter, 1.4. The main result, calculation of the stationary of optical treatment, is formula 1.8 for concentrated photoexcited holes depend on treatment intensity. The author claims that equation 1.8 guarantees that concentration of photoexcited holes in reality that actually means that at a maximal intensity treatment, the number of manganese ions will be exactly 1/2 of what you had before treatment. Why I find this strange? With high intensity treatment, density depends on recombination speed, and your answer doesn't say that. So that's my so I started wondering. So I started to look at the formula. So I see the limit is, so well, I continued reading. In reality, as a result, the relaxation to adjustment is contradictory, so it's by comparing the experimental relation between the spin relaxation time on it doesn't make sense on treatment intensity. As I said, the situation becomes worse because the equation 0.8 in this slide, second line, does not correspond to the preceding formulas. Need 1.7 the equation here, and the text is obvious for QG as a requirement should be met, and not the G is is not explained in this slide. In chapter 2, there's changing entropy of film but the reason is film deformation caused by a reverse Petersburg effect in the base, which has just been discussed. But numerical evaluations for entropy change are of certain interest, yet approximation used and suppositions need clarification. Yet is obvious exaggeration that when the author says that well, she developed a method for new improved magnetic refrigeration technology. As is well known, for refrigerations necessary to ensure adiabacity of the magnetic system well, as it loses magnetism, and the contact the film with base layer is inevitable. The thesis doesn't talk about that. As for the results presented in chapter 3, obviously the role of Veronika Burobina here was only in processing certain experimental data. As she says herself, this was computer modeling of an representation. And chemical composition of the transition layer between the magnetic film and the base layer. So mostly possible gadolinium diffusion. That's what she studied. And assess the overall level of understanding of the physical nature. Is a simple comparison. Let's look at the article, the basis of which chapter 3 is written, and a similar statement from the thesis. So I quoted the English text. So I will not. So I will say it in Russian. So the question, I'm quoting the article. Particularly, the interlayer spacing in films is often significantly larger by 1.5%. And due to the rhomboid distortions. This can be caused by stoichiometry deviations due to apologize oxygen and iron vacancies, gallium or gadolinium diffusion from the substrate, etc. And then, same with reference to the same papers, this is on page 147, says, so the quote was, the interval distance in a film, however, is often larger than in the material, which can lead to a distortion of stoichiometry. And in the interlayer spacing, the original speaks about interlayer spacing. So it was because of diffusion, so it's very obvious. So what was clearly explained in the article became a meaningless statement in the thesis. So which so think there chapter 3. So you honestly processed some data, but since you are the author of the article, you should have a clear understanding of what the article says. So this is a must. And as a result of this consideration, I believe that the thesis by Veronika Burobina in some magnetic properties does not meet the main requirements set forth by the corresponding order on in St. Petersburg University, and the applicant Burobina Veronika does not deserve the degree candidate of physical and mathematical sciences, specialty 010406, condensed state physics. Thank you, Veronika Gennadievna. Please, will you please our comments? I have already mentioned about the excited ions and holes and how I came to the final edge function. So I will. So this is answer about the Rowan formula. Yes, because all the conclusions. All my conclusions are related, and one conclusion is derived from the previous one. So that's how I obtained the result. Veronika Gennadievna, can I answer? So again, you start explaining the general scheme. So I show why is wrong, mathematical. So dear colleagues, please look at line 2 and line line 1, line 2. Does line 3 can it be derived from line 2? And so in this case, I believe that treatment goes to infinity. So we. So can you derive root in second degree is G1 is a constant in this case. So this is very that is a very small value. Dear colleagues, so understand my question. Do you understand when G in the second degree, where G is, so the G will and a constant adjustment? Don't you? Can't you understand? I don't want to. But so there's no mistake in the formula. Okay. You may use your results. You are wrong in this case. The answer is correct. The function describes the material, the element very well. It can describe whatever it like. So we have 4 professors here. So you made a. So we can. So I don't want to affect anybody, and so if we. So there was a question and there's an answer. So I am not satisfied with the answer. But the second and third chapters. Will you please take my questions now? I suggested an. So also a question about the chemical contact, that this can be discussed in future work. So an idea
that the magnetocaloric effect in the absence of external magnetic fields, and we calculated the isothermal entropy, so that this idea can be studied, can be used in future studies of magnetic refrigeration. So in our, so we do not claim that we have created, but you say that you created a method. So we created a method. So the word method, the technique, means an idea that magnetic effect can be used in absence of external magnetic fields. So it can be potentially used for improved magnetic refrigeration. And how will you ensure adiabaticity? At this stage, so this question answered in my future study. We have calculated the change in entropy. We did not create a refrigerator. So why do you say we created refrigeration technology? So you should have said we suggested an idea. So maybe the wording we used was not very good, but we came up with an idea which can be used in the future to improve refrigeration technology. And as for the third question, the attitude to stoichiometry. So these are very general questions, and it can be used to explain many experiments and in what happened in our laboratory. So we grew a samples, and then studied these samples. I didn't ask you about growing films. The distance between layers. What level do you mean? So you say int and then interlevel. Yeah. So which levels do you mean? It should be mid-layer distance. So maybe the translation into English. So I'm looking at your English text. And the Russian, I'm not. Yes, the Russian translation was not good, but in your English text you say inter. So maybe I made a mistake. Okay. So is this the answer? Yes. So time is up. So let's proceed and hear a review by Viktor Vladimirovich Pavlov. So this is of three different types of magnetic. These are three different types of material. So those are quite. The theme is quite relevant for application and scientific research. Use of arsenide hallium as manganese is a spintronic material, and in the first part of the author conducts a theoretical study of spin relaxation in this material, and all the calculations are mostly made on one quality work, Astakov, with other co-authors, and I know that the took part in some experiments, and so I think this part is very important. is quite surprised about the change of such significant spin relaxation at with photo treatment. So maybe I will to the core, straight to the this chapter. So maybe it would be good chapter to look at all the possible mechanisms of spin relaxation in semiconductors, gallium arsenide with manganese, because the author focused on some particular mechanism which has not been described in this chapter. Maybe it's really systematically described and studied, and then which mechanisms are important, which are not. And because of that, the author does not is not quoting important. For example, the Burobina mechanism of 1975 is not quoting some important methods. So I've listed some works, but generally speaking, the calculation is highly relevant, and it's very important that it corresponds to experiment conducted by Astakov with his author, and there's the results are connected with calculations. If we look at the, so when the G's here, the linear member and the G's can be neglected. So maybe the third equation is correct. So let me, the chapter, proceed to the second chapter, which is devoted to calculations of specific changes in entropy or electromagnetic susceptibility in the well-known class of material manganites with well-known magnetic resistance, have high impact, and these are quite well described by researchers. So this work focuses on the opportunity of new approaches to magnetocaloric applications. The author has not so only developed the concept of such possibility. So there is such a possibility, and calculations for multi-layer structures. And then, but I also have a comment in this chapter. In this, the author does not discuss the possible mechanisms of electrocaloric and electromagnetic caloric effects, which could be important when using a field as a controlled impact and their magnetic caloric effect. And even in this case, I'm not sure if it's justified to call it electromagnetic caloric effect. There's no comparison between the possible contributions of linear magnetoelectric effect permitted in materials with certain symmetry and a quadratic magnetoelectric effect occurring in a composite material. So that's all I have to say about chapter 2. The concept itself suggests became the basis for the. So the concept is very interesting and has great practical significance for the use of such type of materials, which can be used for magnetoelectric. So already some companies are trying to build refrigerators based on this technology. Now let me proceed to the third chapter, which is devoted to investigation of iron, yttrium, gallium. So the material is quite well known in microwave technology since 1950s, 1960s. This material is used in the various filters, rotators, phase rotators, and to obtain film, thin film materials of this with this is possibly integrated with other semiconductor materials. So
relevant for spintronics. So the final question here is the stagnatic sort of magnetic state on the interface. So when the becomes very thin, so this this issue becomes highly relevant. So chapter 3, in which Veronika Gennadievna is connected with these issues. As I know, the applicant took not only in calculations but also in the creation of these materials, but of course she was responsible for calculations, and in relation to that she used software Genix. So it should have been mentioned how the algorithm works. So this is missing. So my general concepts, many formulas have come given without numbers necessary, without the necessary references, and in certain parts the style is bad or the presentation is not good. So of course the candidate should worked more on the language, both Russian and English. But generally speaking, I think that these comments don't affect the overall conclusions published in 3 high-rating papers. And because of that, I believe that the thesis by Veronika Burobina, research on magnetic properties of lanthan, strontium, and iron yttrium garnet, meets the basic requirements established by the order of September 2016, 6821/1 on the academic degrees at St. Petersburg University. The applicant, Veronika Burobina, deserves the degree of candidate of physical and mathematical sciences, specialty 010407, Condensed 6. Paragraph 11 of the order has not been violated. Thesis. Thank you. Thank you. Veronika Gennadievna, please. Thank you for your comments. Maybe you are right. I should have numbered all this, but I tried to number formulas which I used further. I also tried to write this thesis in the format of a scientific article, so maybe some methods or mechanisms were just mentioned and not described in detail. And because the magnetocaloric the main conclusions of change of Curie temperature and calculation of the isothermal entropy. So we consider this electromagnetic-caloric effect in the absence of external magnetic fields. And so we came up with an idea, the concept, which hopefully is the opportunity. I will work on this task in the future, how to create a new efficient technology. Are you satisfied with the answer? So there was answer to question 2. I also asked you 2 more questions. So what's your answer to questions 1 and 3? Yes, I should have quoted that you mentioned, and
paid more attention to comparing my results with results obtained by other researchers, but in saying I accept your comment. And second question, you didn't describe the algorithm. Yeah, I should have described this software, so I didn't do. It's okay, thank you. Now we give the floor to Orjani. Can you hear us?
Yes, can you hear me?
Да, вы меня слышите?
Okay. So,
So Johnny, could you please read your review? You have 10 minutes for that.
okay. So, I will, of course, you have a report, so you can read the
You can,
detail.
можете подробно прочитать мой отзыв на сайте.
The PhD work of the candidate Veronika Burobina, basically about how to control magnetic properties of materials.
В основном работа касается свойств магнитных материалов.
I'm with the side materials, so I'm more into the I can make an opinion about the novelty of the part on LaSrMnO and YIG even. And I do believe that
Я считаю,
there are many things
что
try to understand if these
рассмотрим магнитные свойства различных материалов, использование в различном, имеет большой потенциал.
Let's say there is still a lot of work.
И предстоит еще большая работа.
Эта
технология может быть использована в будущем. Считаю, что работа является ценной. Я бы сказал,
are interesting because there are a lot of people working on YIG material, not only oxide electronics, but also because it's the best candidate for interface.
Лучшим стандартом.
But crucial point is
в настоящее время исследования продолжаются.
So in this respect, I was
в
surprised that
этом отношении удивлен тем, что
study of the structural properties
свойств материалов
of them are extremely depending.
Очень сильно зависит.
So, we were discussing about the possibility that
мы обсуждали возможность
actually mechanical strain in the film,
вызванное механическим напряжением материала.
Just comment, because
это просто комментарий. И результат достаточно для того, чтобы результаты интересные, достоверные. И я считаю, что вся работа соискатель заслуживает присуждения ученой степени кандидата. И второй комментарий. Кандидат концентрирует внимание на одном конкретном физическом механизме.
Such a deep understanding of what she was doing, even maybe it was some very interesting discussion.
И это вызвало такое бурное обсуждение.
But she demonstrated to have reasonably under control the matter of she was studying. So,
как соискатель в достаточной степени понимает материал своего исследования.
And
и
that is just a first point to still, I do believe that she deserved the PhD.
Я по-прежнему считаю, еще раз подтверждаю, что считаю, что она заслуживает присуждения степени кандидата физико-математических наук. Thank you. Как я понимаю, у вас нет конкретных вопросов. Но мне кажется, вам уже задали очень много, слишком много вопросов.
Have you checked the structural features? You say that you saw the increasing of interlaying.
Например, один из профессоров спросил по поводу увеличения межуровневого расстояния. К сожалению, мы вас плохо слышим. Hello, we cannot hear you well, says Veronika.
The question was, you discussed before the possible off stoichiometry, oxygen vacancies. All these features can be traced back by X-ray diffraction. Because, for instance, oxygen deficiency produces an increase of the lattice parameter, and so on and so forth. So, did you check the structure of the film that you have analyzed and grown?
Изучали, проверяли ли вы структуру пленки, которую вы анализировали и вырастили? Да, большое спасибо, это очень хороший вопрос. Когда я попыталась впервые вырастить эти тонкие пленки, я получила пленки огромным roughness. Шероховатость была 20 нанометров подложки. 20 нанометров. Поэтому для меня это было совершенно невозможно использовать SLD и эту методику, чтобы проверить хорошо пленки. Поэтому я сконцентрировалась на магнетизации этих пленок. Я использовала SQUID, чтобы зависимость магнетизации от температуры. Я использовала... У меня не было рецепта, как вырастить эту пленку, используя PLD, потому что никто не использовал такую систему для выращивания этой. И поэтому мне нужно было найти рецепт, как вырастить. Но для конкретно этой работы, которую мы сейчас обсуждаем, я использовала SLD, чтобы проверить качество своей пленки. Когда речь идет о лантанистронце марганце. И когда у меня была возможность вырастить гранатовую пленку, я ее проверяла методом SRD, но они не описаны в моей диссертации.
I'm satisfied. Even though I didn't get chance to position, but I'm satisfied. There's some problem with the connection, but
он слышал русский текст, видимо, текст.
I didn't hear you, but
Я вас не слышал.
but not the second part. But
Не слышал вторую часть.
My question, in the sense that you care about, you did investigate the structural properties of your field. So maybe
Могли бы вы коротко повторить вторую часть своего? К сожалению, для выращивания мне не удалось использовать LSD метод, когда у меня была возможность вырастить гранатовую пленку. Да, я использую несколько методик, в том числе SRD, чтобы рентгенские исследования, как же можно проверить качество пленки. Их можно также использовать для проверки качества пленки. Таким образом, я частично применяла SQUID, но конкретно для этой задачи мне это было достаточно, чтобы знать качество своей, чтобы удостовериться в качестве своей пленки. Что касалось магнетизации, что нужно для моего исследования магнитогалорийного эффекта. Я удовлетворен ответом. Большое спасибо. Okay, so now let's present my review because everyone else has. I'll try to make it short. I will not read the thesis is dedicated to some magnetic properties in 3 different materials. Materials properties are considered. So the research is these parts are connected only by the name. The first chapter is a theoretical analysis of the dependence of spin relaxation of electrons on the power of optical excitation. The experiment taken from the article by Georgy Astakov et al. The theoretical modeling described in this chapter is based on the article where Veronika Gennadievna is Binek, Christina Binek. Yeah, that's. Did I get to describe the dependence of spin relaxation time and optical intensity? Kinetic equations are used. Well, I would like to say that the model itself, the mechanism of extension of spin orientation has been suggested in Astakov's article. So Veronika Gennadievna may only claim to be the author of the calculations she made. That's how I understood after reading the article and the thesis. Unfortunately, the modeling contains no analysis of parameters, limit case, extreme cases, which speeds are important and not. But this I have already mentioned in my comments. I have already, moreover, the analysis of formula conducted by Dr. Kuchma and myself show that the formulas are very contradictory and cannot be trusted. So the relation is so simple that any root relation can be described this effect very easily. So it's not clear. So what's the actual result of chapter 1? Chapter 2 is description of magnetocaloric effect, and so this Veronika Gennadievna made a presentation, and already at that point we advised Veronika Gennadievna to claim not to call herself the author of the new refrigeration technique, because that's a very important issue. The idea has been presented, and again I'd like to say that the impact of deformation of substrate to Curie temperature in this magnetic film has been studied by another author. Am I right? And that is why Veronika just suggested an idea. The idea is good, and even more so that such simple issue to make this technology work, you need adiabasity. So it is impossible to achieve this. The calculation is based on entropy, so it's not clear how this calculation related to the idea itself. In chapter 3, the author is given results of experimental studies of the chemical composition of film, which contains ions, but the magnetic properties have not been studied. This contains structural analysis, many experimental data, and Veronika took part in processing the results of several experiments, but because she is given many results, she has every right to call herself a co-author. But we still have some questions in here in your present. So can you show some of the pictures in your presentation? Could you? Can it tell you exactly? In your thesis, this is figure number 14. Number 14, figure 14, epitaxial technology, the oscillation curve of quick electrons without any comments. What does it mean? What does it show? What causes these oscillations? This experiment was conducted by one of my colleagues, and as you can see, the signal is suppressed when the film becomes thinner. And does the signal get reduced? Diffraction of quick electrons is a well-known method, so that's a very important question. So which exactly slide in your thesis? The figure 14. Okay. In this case, so this just shows how step by step how thin films are grown. I ask what causes oscillation, because reflected from atoms proves periodicity of the structure. I see. And now figure 15 shows magnetic response in garnet films, and this is resonance peaks. So how did you measure those? Which figure? Figure 15. You don't have the thesis with you? You can have a copy if you need it. Okay, so what is your question? How was measured? What exactly? The curves shown in this, which figure? Figure 15. I didn't take part in these measurements myself, but you show them in your thesis. So this work was co-authored. I was a co-author, so I needed the results of these measurements. So that's why I used these measurements for further analysis, but I did not take part in these measurements. Veronika Gennadiyevna, since you're showing these results, so you must you must understand. Yes, I understand the results because figure 16, same question. So was what is on vertical? So this S12 on the vertical axis. Just a second. So these questions. Spin propagandation probably mean. So I did not study this and I didn't learn this in Russian. So I can help you with translation. But S12, so what's this value? What does this value mean? And how was it measured? As I said already, I have not taken part in this experiment, but figure 30 shows many curves. Says something is said about them in the text. Were these curves, the blue curves, obtained? These results were obtained by one of my colleagues. My task was I was involved in analysis of, I was involved in SLD and modeling. So you never mentioned I say that I was a co-author. So since you are using these results and these figures, so you have to send them. In my thesis, I did not explain in detail because in the future it used in a thesis of one of my colleagues, and my colleague will be able to explain it. Let's say figure 22. Experiment shows an experiment, your theoretical curve. Yes, I was personally GenX. So do you know this software? So please don't ask me questions. You used a 4-layer model. So what which peculiarities of this curve? So this curve is an oscillating signal, and to create a layer model, this curve has to provide enough information. So to create a signal, you need a 4-layer model because it is impossible to use fewer layers to create this curve. So what is marked on the X dependence on wavelength. So which in physical terms, the moment, which moment? So lambda is what? Is the wavelength of no light in this formula. Which light is? You have X-ray have X-rays. So X-ray is not light. So each moment is transmitted. And why is it there's not? I thought everybody knows that. I thought everybody knows that. I have many questions, so I have limited. So for this chapter, as I could see, you cannot comment most of the results that you have included in your thesis. So your main answer, you adjusted one curve, the experimental results. So they describe the growth of material, especially a multi-component compound. You need. Did you grow the film? If I didn't grow these films, says important to grow, use such universal technology is complex task. So as I understand, films were grown by the group of Nikolai Simonovich Sokolov, and I belong to Dr. Sokolov's group, and that is not explained in your thesis. Especially Nikolai Simonovich published many papers, and this article where you are a co-author. So your role in growing the field made me ask many questions. I started working with him not a very long time ago, and what our cooperation was so successful, I was able to publish. Nobody in Sokolov's laboratory used Genix and find application for this software in our laboratory because this software is quite universal. I see. Conclusion. I will not ask you many questions, just comment. In the Russian text of your thesis, I looked at Russian text contains many unclear and ungrounded statements. In magnetic has there's no evidence, there's no assessment of efficiency. Decay. This term is not used in Russian. Spin is a fundamental characteristic. But decay, polarization, decay or relaxation, this expression is used, spin or relaxation, decay in the English text. Okay. Say that the author developed methodology for new improved magnetic refrigeration technology. So we already asked you not to use this, to use this. A person wrote an article on prolonged spin relaxation time. So it's natural, and you don't have to emphasize that prolonged. You don't say the Russian expression is not good. So prolonged decay time, but in the Russian expression is not good. Russian equivalent is not good. Provisions for defense consistent with experimental theoretical dependence of spin relaxation shows that the increase of relaxation time of electrons really depends on concentration of very excited holes on manganese with increased treatment power in stasis simulation confirms the result obtained by other authors. So I can see a new concept of changing. So this has already been mentioned. The interlevel already discussed. The examine the dependence of film thickness. The thickness cannot depend a signal. Neutron polarization. What's neutron is not clear. And part of nuclear density also is not clear, etc. Generally speaking, dissertation thesis of Veronika Gennadievna is a composition of 3 studies, and the results of the study contain no novelty, and the conclusion of the author about the value is on the change of entropy is not based on actual efficiency of the process. As for the 3rd study aimed at determining the chemical composition of magnetic films, it's not clear from the thesis. It's not the contribution of the author is not clear. Based on the above, I believe that the thesis by Veronika Veronika on the theme study of magnetic properties of highly arsenide manganese, lanthan strontium manganese, O3, and yttrium iron garnet do not meet the requirements established by the order 1st of September 2016, C21/1 on the order awarding academic degrees at St. Petersburg University. And the applicant, Burobina Veronika, does not deserve the awarded degree of candidate of physics and mathematics, specialty 010407. Can I say? Thank you. Okay, now you can comment, answer my comments. My review. You say that we took some results of the paper. I'd like to say that these results were obtained in 2007 and presented as master's thesis same year, and I won 3rd prize at St. Petersburg State Electrotechnical University as the best project in 2007. As for developing new efficient technology, of course, that's one of my potential tasks for the future. And as I have already said, Dr. Christian Binica, we suggested to use this effect in the external magnetic fields with voltage control, and this work can become an idea for future research. As for equipment efficiency, so we have not produced any equipment and hardware, and efficiency can be assessed in the future. And as for my role, study YIG films, I wrote a separate chapter dedicated, and anyone can read this chapter. It's in my thesis. Maybe I did not give any detailed descriptions of the methodology, because I said that I tried to stick to the style that could be used in a scientific article. It's sufficient to make reference, and then the reader may follow use this reference link to understand this question in more depth and read about this in other sources. Well, by the new concept, I mean new idea. That is why I used this term in my thesis. As for the absence to efficiency of the effect, I think you may read magnetic refrigeration. There is a lot of literature to learn about contribution, my contribution in science and in development of Magnetocaloric Effect. It's not only me, but also scientists. This is a very fairly interesting new idea. So, well, I think that's all for the time being. Okay, thank you. Colleagues, do we have any external does a reviews so let's pursue additional discussion of the thesis of the councils. If you have any questions, so please. So does anyone have any questions? I would like to go back to the answer of my question. Formula, which we. So you said the formula is absolutely correct. Yeah. I don't. So this shows that our function ideally describes our experiment. Our result, line 3, cannot be derived from line. Veronika, so let's you say. So there's my question. One is goes to. So this is your definition. Then you have a formula, the root of, and then that line 3 can be derived from line 2. Do you agree that this is nonsense? 3 cannot be derived from line 2. See that is nonsense to dig in details and to conduct research and to an article in a famous magazine. This is important, and I believe our results are important and significant. So this is my answer. There's no blackboard. Anatoly Evdokimовich is useless to persuade. Veronika Gennadievna said that many times. So please get personal. And let's go back to the answer. One thing to dig limits, and another thing is to publish an article. Sometimes the article is not clear. And so I feel sorry for your co-author who put his name on silly paper. So this formula is very simple. You can take g second degree out from the root. G minus 1 taken out, and then is 1 plus small member g, and then so then you get the formula given in the beginning of your paper. Very simple formula. G degree and g. You have to honestly G has to be taken out from the root, and then you have a minor value. Can I write a conclusion? Can I write it on paper? But in my review, I say the formula, it contradicts the previous equations. So already in your own equation. So if you don't like to dig into details, I checked, of course. So that's not how it is. So this is written not only by me, but also by Christian Binek, who put his name on this. And you said you wrote this article by yourself. So what other comments do we have? Comment. So this formula, first of all, I have already explained. Your limit expression contains no probability of recombination. This is that way. Secondly, even if you G1 in work consists of what? Recombination speed and combination of manganese holes. And what about recombination between zones? Where did you explain this? You forgot this recombination. You never mentioned this recombination. And high intensity, this process play a very important role. So talking about extreme values with explanation, because there's many questions. That's just to continue with my comments. More comments. We have more comments. More comments. Then let's proceed to the final part of our discussion. A speech of the academic supervisor, Vladimir Ilyich. Take the floor. Thank you. Thank you for giving me the floor. So where's you? I've known Veronika Gennadievna for a long time, since she's been a student of our the department established by Joris Ivanovich since 2003. Between 2003 and 2016, I was the head of that department. And when he reached the maximum age, so I know all the scientific and academic progress of Veronika Gennadievna. In 2007, she graduated was awarded the master's degree. Study of spin relaxation in manganese arsenide. So she conducted this work, and her advisor was Kirikin, who later, together with Korinev, who was opponent of this work, together with Astakov in 2008, published an article, a paper, and for some reason clear to me, they never included Veronika Burobina, never thanked her for the calculations, even though Kalorkin said that the calculations enabled a qualitative model included in the future publication. And then many, you mentioned Astakov many times, as so I feel I worked in this department, the staff of Kuriner, they graduated our department, so something happened, but the cloud has a silver lining, and today at St. Petersburg Electrotechnical University, so we decided that new students should know what each department is doing, so the best works will be published, and master's thesis, the name of which I have already given. So Veronika Burobina's master's thesis will be published on her university institute website, and anyone make in the future refer to this work, and I think that Astachov will also have to refer to Veronika Burobina's work, who in her master's thesis, I will read just one sentence, where Kalokin says, calculations enable us to create a qualitative model that will be included in a future publication. In 2011, she continued her education in the US, where for which she won a grant from Osmer Fellowship Award. So she worked as an assistant professor, continued her research. So she continued with the theoretical processing, and so published a work in the same on the same theme. So won a master's degree in physics at Utah University. She has a good theoretical training. Her professors were Vladimir Pirel, and who was a professor. She studied under many distinguished professors: Konstantinov, Oleg Vladislavovich, who taught Skobov, Valery Grigorievich, and in Utah she studied under Efros, great theoreticians. As a future scientist, she had very good theoretical. And then before her master's thesis, after her master's thesis, she joined and Zakachenia invited her to prepare. Boris Petrovich passed away, and Korenev continued an opponent of this paper, and he said that it's the number of neutral acceptors grows, so thus the theories proves the mutual compensation model. The work is with an excellent mark. The scope of Veronika of scientific interest is quite wide. In addition to theoretical study, helium arsenide, she was involved in many experiments which evidenced by papers, the presentations made at international conferences. She also studied magnetic properties on the multiferrate lanthan strontium plumbum etc. And one of her latest studies is a study of magnetic properties of YIG GaAs. In 2018, she conducted a study in Trieste, Italy, measurements of super thin films. So the films were grown in laboratory, and X-ray, of course, was used. Was applied with synchrotron, and of course, well, an interesting task was the idea to develop the so-called magnetic refrigeration technology in the area of external magnetic fields, where she personally grew the materials by method of impulse laser coating. So all this proves that Veronika Veronika is an independent researcher who can. So she published 3 papers in high-rated magazines, Applied Phys Letters, Applied Physics, and the total average index of these journals is 10. So that corresponds to publishing an article. It's like 20 articles published in magazines. And considering how careful articles for these magazines are selected, there's got 2 reviews. So can we make it a little bit shorter? I think that the work of Veronika Veronika proves that she's an independent researcher who's capable to deal with complex, and she deserves the degree of candidate of physical. So the response to all the necessary, all the requirements. Thank you. Okay, now we proceed to the last item, discussion of the members of the Dissertation Council, the awarding degree for that period. Please postpone broadcasting, stop broadcasting, and all the attendees and all the colleagues and also the Dissertation Councils are kindly requested to leave. I'm sorry, but said, so please say so now.
Let's resume session. Please discussing and make sure we are here. Now, the awarding the academic degree to Veronika to the open individual voting. Be reminded that the decision of the Dissertation Council be considered on awarding the academic degree should be considered positive if more than a half, but not less than 3 members of the Council taking part in the session, according to Article 23 of the procedure for awarding academic degrees at St. Petersburg University. Appendix 1. Let me draw attention to 3 possible answers: for, against, and abstain. Have 3 options now. In the order discussion, LaSrMnO3, your opinion? My opinion is yes. Thank you. Kuchma Anatoly Evdokimov, remember your opinion? I still have my opinion. Against. Pavlo Vladimirovich, your opinion? Yes, I think my opinion is for. And Council Member Professor Orjani, your opinion? Again, we didn't hear you. Could you explain? I still cannot hear you.
Can you hear?
Тебе слышите?
So my opinion is yeah.
Мое мнение да. Thus, myself, a chairman of the council, Ignatiev, my opinion, after session, with careful discussion, I will have my opinion. I'm against. So can we repeat the procedure, please, because the camera was moved. Can I continue? Vlasenko Council. Your opinion? Yes. Council Kuchma Anatoly Evdokimov, your opinion? Against. Council Pavlo Viktor Vladimirovich, your opinion? Professor Arjani, unfortunately we have to repeat through the procedure for technical reason. Your opinion, can you please say your opinion?
My opinion is yes.
Мое мнение да, за. Chairman Ignatiev Ivan Vladimirovich, my opinion is against. Now let me count the vote. 3 members voted for awarding the degree, against 2 members. 2 members, no one abstained. So on the basis of the open individual voting of members of the Dissertation Council, the decision to award the degree of candidate of physical and mathematical sciences, specialty 010407, Condensed physics, to Burobina Veronika Gennadievna. Let's give the floor to the candidate Veronika Gennadievna on awarding the degree. So your final place. Большое спасибо, профессор Аджани, то, что вы были с нами. Я хотела также поблагодарить доктор Павлов, доктор Власенко за вашу поддержку, поблагодарить доктора Кучму и доктора Игнатьева за ваше мнение, за поддержку моей работе. Хотела бы поблагодарить моего научного доктора Кучинского. Большое спасибо. Thank you. I declare the session closed. for your participation. Please online broadcasting.